Jingbo Wang.
Imagine on a hot summer day, you take out your favorite can of soda from the fridge. That is the sound of happiness. Well, in science, it's actually the sound of CO2 leaving the water. We love CO2 when it's our drink, but we do not want too much CO2 in the atmosphere. You probably already know this. In less than 200 years, human activities have increased the CO2 level in the atmosphere by 50%, causing a global temperature to increase by at least 1.1 degrees Celsius. In order to avoid the negative impacts from global warming, we need to remove a huge amount of CO2 from the atmosphere, about 500 billion tons. So how much work are we looking at? Take the world's largest CO2 capture facility. We need to build 1 million of such plants just to offset CO2 emissions from human activities. And even more plants are needed if we want to bring down the CO2 level back to pre-industrial level. As you just learned from the trivia, here at Berkeley National Lab, scientists have formed a carbon negative initiative to work together on removing CO2 from the atmosphere. One approach is to find a sorbent that can pick up CO2 from the air. You can think of the sorbent as a special sponge that can absorb CO2. Like every other sponge, CO2 needs to be released before you can reuse the sorbent again. And usually heat is applied to release CO2 and regenerate the sorbent. In one cycle of capturing and releasing, 80% of the energy goes to sorbent regeneration by heat. If you recall the scale of CO2 capture we just talked about, that requires a lot of energy and money. Our research team is developing a cheaper and more energy efficient way to directly capture CO2 from the air without using heat. It's a three-step process. First, we start with a liquid sorbent, which is a base solution that can selectively react with and trap CO2 in the solution. In the second step, we zap the solution with electricity, which triggers electrochemical reactions. In this process, our solution turns to acid and CO2 is released. Then we can collect a concentrated stream of CO2, either sent to deep underground for storage or use it to make other products like soda and even fuels. In the third step, we turn the acid solution back to base by using the byproducts from the second step. Now it's ready to use for the next capture cycle. By only using renewable electricity instead of heat as the energy input, our process can bring down the cost to capture 1 ton of CO2 from $600 to only $100. In the near future, your favorite can of soda might be made of CO2 directly captured from the air with our technology.